In this video, we are going through a step-by-step agent framework demo for the pharma supply chain industry. And we're going to show you how simple it is to build an agent on Databricks and combine it or connect different SQL tools. So Lara, let's go through the problem statement.
Yes. So starting with all the questions we typically get when working with supply chain. Do I have the inventory? Do I have the capacity, whether it's materials or persons? What are the expected delays for each manufacturing stage? How is this going to affect the downstream stages and impact distribution, revenues? And how can I absorb those delays? So those are problems that we're trying to solve. And what customers try to achieve generally is first to predict how a delay and cumulative delays will impact, for example, in the pharma supply chain, patient service, cost, inventory, versus just having a historical view of the supply chain, with the aim to then prevent, so mitigate the risk by having some prescriptive interventions to reduce the lead time and prevent having excessive inventories. You want to optimize that. You don't want to have inefficiencies, etc., especially when there's a deviation from what was planned. But when you're trying to do this, there are generally some challenges on the way. What we typically see is first, very often your data is going to sit in multiple silos. So you need to, in order to have accurate predictions, you need to leverage all the data that is available to you. So that can be sales, promotions, inventory, consumer signals, events happening, at different parts of the supply chain, and very often that sits in different systems. Second, one problem we often see is going from batch to near real time or streaming. This happens when supply chains rely on legacy systems, and so that can cost a lot of money if you're not able to predict in real time when it's required. And finally, the third problem that we see is when predictive tools are not accurate enough, and that means poor predictions means you cannot prevent inefficiencies effectively. So those are the challenges that we see. And today we're going to see how, by building an agent, you can try and address those challenges. Going back to basics, we did some videos on agents, so we encourage you to go and watch them. But what is an agent at very high level? It's basically an LLM that acts as if it had a brain. So when you build a Gen AI pipeline, you can hard code the steps that an LLM will do. You can say, first, summarize this text, then do sentiment analysis, then retrieve some relevant content from a vector index. But the next step that you can do, instead of hard coding, is offering that as tools that the LLM can leverage and decide when to leverage for tasks in order to solve a problem. So here you can say, hey, can you help me return my last order? And it can reason about what to do. It can find information and then leverage some tools in order to solve that problem. So instead of telling the LLM what to do, we give the LLM the flexibility to choose how to solve a problem, which means
We let the LLM reason about the tools it has to use to solve the specific task.
exactly, yes, exactly that. And what you end up with is that you can call functions in Databricks, functions, so tools defined as functions, to build those agents. So let's take the example of question of what are our top 3 forecasted raw material shortages? Your agent, prior to that, we're going to give it some tools. So for example, the ability to look up a database, to leverage a Python interpreter, or even to call an ML model that does predictions, for example. Your agent has those tools available to it, and it's going to decide which tool should I leverage in order to answer this question. It's going to decide which ones, and it's going to call those tools. Those tools can return some kind of information, And that's when the agent, like the LLM, can then leverage this information in order to generate an answer. And so, for example, here, the top 3 forecasted raw material shortages are la di da da. So that's in a nutshell how an agent works. Now, the question is, how do you build the agent? In Databricks, you will build functions. So functions are defined in Unity Catalog, and they can be used by the agent in order to execute those tasks. And the advantage, as we said, is that the agent has the flexibility to choose the right tool for the task. So depending on the task that you give it, depending on the question that is raised, it's going to choose different tools. The reason functions are so powerful in Databricks, one thing that I really love is the fact that you can govern these functions, especially in the pharma supply chain and in regulated industries. Cannot highlight enough how important it is to have, governance and the proper guardrails when leveraging those tools. You don't want people to leverage tools they should not have access to. And if you want, for example, to leverage a vector index with the unstructured data, you can govern it as well with the same governance model. So you can leverage a vector index for unstructured data, you can leverage classic ML models, you can leverage just tables and have the agent query the tables. All of this is under the same governance model, which is Unity
Yes,
Catalog.
that is a very good point. The common governance model across any AI tool, asset, model, data engineering, right? It goes from source till an actual application. So that is really key point.
Exactly. And when we look at a supply chain agent, what is it going to look like? So again, you're probably going to leverage some structured data. For example, your inventory. For that, you can leverage a Genie space. So Genie space, we're going to see in a second how that works. But you can create a function linked to the Genie space via the ID of the Genie space so that you can leverage it as an API. That means you get a text-to-SQL agent that can be leveraged. Genie spaces are great for structured data, but what about unstructured data? You can build a vector index. So for example, if you have images of vaccine batches, in the case of a pharma supply chain, scanned invoices, feedback forms assessing, vendor performance, comments from plant worker or manufacturing staff. Here again, you create a function that will query the vector index and get the results back based on a question.
So then we have Genie for text for text to SQL on structured data. We have SQL commands on structured data through tools and some other tools like Python implementation of tools.
Yes, can
Yeah.
have that as well. Exactly. And just to double click on how that works as part of our Mosaic AI offering in Databricks. So the way you register those tools, you register them as functions. And you can see here, they are, registered just like any table, any ML models, which is why you have Unity Catalog governance over those functions alongside tables, vector indexes, etc. And Unity Catalog, the great thing, the reason that it works is that it will provide the metadata required by the LLMs for tool calling. Because in order for the LLM to understand when and what tool to use, it needs to have a bit of information around the context of the tool. What should it be leveraged? You need to provide that metadata to the LLM so that it can learn when to use the tool. And so that's the way that we register it. And so before we deep dive into the demo, just a quick recap of our end-to-end platform in Databricks. You can obviously prepare the data, ingest the data. You can build some, ML models, for example, prepare your features, prepare a vector index for your unstructured data. When you build agents, they can leverage Gen AI models, but also classic ML models. We're going to see that in a second. And you register the tools as functions, as we discussed. You deploy those agents, and you integrate that within your MLOps framework on Databricks. And the great advantage also is that within Unity Catalog, obviously, you get the advantage of having the lineage between all those components. And one thing that Databricks has been innovating a lot on is evaluation and data quality. So there are a number of things that you can leverage in order to evaluate the outputs of your agents, either by leveraging LLM judges, so an LLM that will evaluate the output of your agent, peer labeling, tracing, a lot of things that can be leveraged. And again, this governance aspect that we discussed. So that's the end-to-end platform that we're going to leverage here. So now if we go into the demo, we're going to build an agent that can get an accurate vision of our stock and provide fine-grained forecasts and allows us to do stock optimization and demand forecast. And here we take the example of a pharma supply chain. So it's a simplified example, obviously, with 3 plants that deliver 30 product SKUs to 5 distribution centers. Each distribution center is assigned to a set of between 30 to 60 wholesalers, and each wholesaler has a demand series for each of the products. And here the assumption of the data we already have is we have a demand series for each product in each wholesaler. We have a mapping table so that we can see the relationship between the distribution centers to the wholesaler. We have a table with the cost of shipping, maximum quantities of product that can be produced from each plant to each of the distribution centers. And then we created some fake unstructured data, some emails from supply chain managers that are alerting of delays occurring from distribution centers to wholesalers to illustrate how you can retrieve unstructured data from those emails.
Amazing.
So that's what we start with. And this is how we're going to build the agent step by step. We're going to first build a 1 week ahead forecast to estimate next week's demand for each wholesaler, distribution center, and product. We're going to optimize the transport costs. So those are I would say, like the individual components that we're going to leverage in the agent. Then for all those emails saying, hey, there's a delay, we're going to build a vector index because it's unstructured data. We're going to build functions, so define all of those components as tools, as functions in Unity Catalog. And we can then query the data, like the structured data in natural language using a Genie space. And then, based on all of this, we're going to build an agent based on all those functions, and then we're going to evaluate the agent. So easy, 7 steps to follow. So now if we go through this step by step, so the first notebook we're going to look at is fine-grained demand forecasting, where we do the 1 week forecast estimate. So here we're using Holtz-Winter seasonal method, but there's 2 things I'd like to highlight. So first, I did not write this notebook. We're going to go through it because it's interesting, but I actually leveraged this from a solution accelerator that we have in supply chain. The reason I'm saying this is that in order to build an agent, you don't need to be a data scientist or an ML engineer. I can consider that as some data science logic that I leverage, but it can be a complete black box to me. I can ask you, Maria, you're a data scientist in another team. I can say, hey, can you build this demand forecasting for me? Then I can take this and define it as a function to build an agent, but I don't necessarily need to understand how that works under the hood. I can just leverage it as some logic and replace it with anything, really.
Interesting. So then it's a really nice way to collaborate with people with different skills, right? So you ask the data scientist to write the logic of a modeling or forecasting. You wrap it in a function and then you just query it.
Exactly. Yes, exactly. We're still going to go through it because it's always useful to see how to build things, and it's a really cool accelerator. But yeah, so here, what we're going to do is using this method in order to do demand forecasting. One thing I would love to highlight, because we see a lot of customers, they love using this, is using Pandas UDFs. So user-defined functions really allow you to take some data science code in Python, and instead of applying it to a single node, then you can distribute it. You can leverage the power of Spark to parallelize this across multiple nodes. So we're going to see how to do that. And then what you end up with is an aggregate forecast on the distribution center level for each product. And so you get this, horizon of 1 week predicting into the future. The way that they did this, so here they define, the function that leverages this method to do some forecasting. And here, this is where we're going to leverage the Pandas UDF. So maybe it's good to spend a bit of time here since we get a
Lara,
lot.
can you zoom in a bit? Sorry.
Sorry?
Can you zoom in a bit?
Yes.
Thanks.
Is it better?
It hasn't. Yes. Yes.
Better?
Yes.
So here we can focus a tiny bit on the Pandas UDF. So for people who don't know Spark processes data in partitions, right? So here we want to combine the ability that Spark has of like scaling your data processing with like the Pandas time series forecasting. And so that's why we use applying Pandas. So here we start by determining the number of unique product and wholesalers pair, and then we redistribute the data across partitions so that we can do some parallel processing across each partition. And so when we do that, we use product and wholesaler as partition keys, and that really ensures that each combination of product and wholesaler are grouped in the same partition. And that's how you can do parallel processing. And then applying Pandas is basically having this Pandas UDF executing this one step ahead forecast function that we defined before. So that's the UDF that's written in Python and operating on a Pandas data frame and, performing the whole winter's forecast for each group of data here.
So in this one step ahead forecast, we have all the modeling logic mainly that we then apply with this applying Pandas method in each grouped key product and wholesaler.
Exactly. Yes. So I thought that's a really cool way to do it and show like the power of Spark. And then what they did is just aggregating the forecast on a distribution center level and then just saving it to Delta.
Excellent.
So that's one logic. Then the second thing that they did was to do some graph processing using network X and then graph frames. Also here, so that what this allows us to do is just to see the product material relationships so that you can see the parent-child relationships and the quantities that are needed in order to produce a product, etc. And so here they also show like how Spark and graph frames allows you to do some parallelism and, which allows you to scale. So again, here, I don't want to spend too much time because we want to talk about agents, but because this is a really cool accelerator, we can see a bit how they do it. So first they look at the demand DF forecasted delta table that we just created, and then we read the bill of materials that just gives you all the relationships between the product and the raw materials. Then you transform that into graph edges. So you have material in and material out, and then you're going to convert that to vertices here. And then when we display it, we have it here. And that allows us to build a graph frame using those vertices and edges, and then deriving all the relationships with a function that tracks which materials are required for specific products. That's the function that does it. And that's the results that you get. So you can calculate then the quantity of raw materials that are needed for specific products. And then we can combine that into a single table. And then you can also obviously compute the raw material demand and save it as a table as well. So we have this logic, but again, I don't need, if I build agent, I can ask a specialist to build that. I don't need to be a graph processing expert. And this is just an example of how to optimize a supply chain, but you can take any logic. It doesn't have to be just graph processing and, time series forecasting. This is just an example. The third thing that we're going to do is transport optimization. So here we want to minimize the transportation costs based on some mathematical constraints that we have. So if I go back to the top, so yeah, quantities shipped must be 0 or positive integers, sum of product shipped from one manufacturing plant does not exceed its maximum supply, etc., etc. So here's just an optimization exercise. And here again, we're going to leverage the power of Pandas UDFs. So here you start by defining and solving load planning. So forecasted product demand, max supply, and shipping costs. So you all have that in a table here. And then you can see here we have now a transportation cost table where you have one line per product and plant. So you can see our products here. We join the transportation cost, supply and demand tables into a single data frame so that we can optimize that. And here, that's the function that solves the optimization problem. So that's the function that we're going to apply to optimize. And again, here, this is where we define a Pandas UDFs that takes this function and, apply the logic across all the partitions. And we save it to Delta. So we have all those useful tools that the agent can, intelligently leverage in order to solve problems for us.
So then are we saying that if we are a business now and we have a data science team that has built, 3, 4, 10 of these models, then are we thinking a model as a tool that then we can leverage through agents?
Yes, exactly. That's
Okay.
why I don't know what you think, Maria, but sometimes people are always like, classic ML is dead. It's all Gen AI. And I really disagree with this because I think the best solutions that I've seen in customers is always when they try to leverage a bit of both. And you can leverage all this really sophisticated logic into an agent to build decisions. So I think that's really interesting.
Very good point, yes. So traditional ML is not dead, and on the opposite, you can combine it with agents to solve much more interesting problems.
Exactly, yes. So now we're going to build a vector index for our unstructured data. So here I have a table. Those are fake emails that I created because we had this solution accelerator, but then I wanted to have some unstructured data as well to show the power of the agent. So it's really simple, just have a date and then content, which is unstructured data, it's text, with a guy named John Smith. I was not very creative on this. Supply chain optimization manager saying, hey, there are some delays, blah, blah, blah. We have this delay, it's impacting this, etc., etc. And so then you have like lots of emails. And so what you can do, we have a dedicated video showing how to create a vector index. But what you can do is create a vector index that looks like this. And from the table, you can do it programmatically, of course. But otherwise, you can just create vector index, giving a name, then a primary key. So for example, date, you can select, an endpoint, columns to sync. So for example, the content here, which are the emails. You can either ask Databricks to compute the embeddings, so give the text a mathematical form, or if you already have computed your embeddings, you can, bring them and not recompute them. The embedding source column, so it's content. Can use any embedding model, so for example, BGE. And then you can sync on a triggered mode if your data doesn't change often or continuous, and click create. And everything that I just shown, obviously you can do it very easily programmatically. So I do that, and then it takes a few minutes to come up, and you end up with this vector index. So that's where I can store all my unstructured data. And here I choose emails, but it could be images, invoices, whatever you need that is not structured. All right. So now this is where it gets interesting. So we're going to build functions that leverage the tools that we just defined in those, create tools as functions. It's a bit, you can use any word, they'll be interchangeable. It's very easy, so we're going to do that in, I think, 2 notebooks, but we're going to define a function that takes raw material as input, returns all the downstream relationships. Another one that takes a product as input, returns all upstream relationship. Then we have a function that calculates the risk of revenue loss due to raw material shortages. So if you let me get into the notebook. So first, there is some data analysis that is being done in order to identify the critical raw materials and potential shortages. So again, here, there is some, logic that either you can do or you can ask, somebody else to do. So for example, a data analyst in this case. So you can do this data analysis to define that. And now, that's where I'm going to define the function. What I really love about it is that it's so easy. It's as simple as saying create or replace function, giving a name. Here I have the catalog, schema, and then, name of the function. So that's registered in Unity catalog and I can govern it. And so you give it, you have input material with a comment about, what this is. And then this is very important. This is the comment around the function so that your LLM knows what is this function about, when should I leverage it, and for what purposes. And so that's registered in Unity Catalog. That gives the context to the agent on all the tools that it has available to it. So here you get product from a raw material. You give it a raw material, you get a product.
Sorry, so this, the tool you described, is just a pure SQL tool.
Exactly.
So right? Nothing else is happening here. Any SQL, is it the SQL query you were executing above, just wrapped into a tool?
Yes, exactly. So you have this logic here in order to, and the function leverage this logic that you define here.
Excellent.
So I don't think here this leverages any function predefined. I think it's just a copy paste of all the logic.
Cool. So then the logic of the tool sits in the tool and the comment just explains what is happening inside. So, and that is the only thing actually the LLM uses as metadata to understand what the function does. And
exactly.
if it is needed to hit it or not.
Exactly. And this metadata is available in Unity Catalog, and it's important for the LLM to understand the context. Because the more information you give it, the better the more your outputs are going to be conforming what you want the agent to actually do. So yeah, that's very important.
Also, I guess the LLM also accesses what it requires as input. So this function requires as input, the input material, right?
Exactly.
So that also the LLM has access to. Mm-hmm. And I guess it has to have a specific output.
Exactly.
Define later. Okay.
Exactly. And so here we had a product from a raw material, and here this is the inverse. So here it returns the raw and intermediate materials that are required to produce a particular product. And so again, the context is very important. And here I give the way that it's going to get the required information. Here is the context and here is how to get it. And so here, for example, I can like leverage this function, like specifying syringe, and then get all the raw materials that go into producing a syringe. And likewise, like for example, raw material, this one, like is present in this particular product.
Okay, so here you're just hitting the function you just defined above.
Exactly. Again, in SQL,
Yeah.
it's very easy. Then we're going to create more functions. So here there's one that calculates the risk of revenue loss due to raw material shortages. And so here again, you give it some SQL logic that you can build or any data analyst can give, and then you tell the LLM that this function, what it does is to return the forecasted revenue risk due to shortages for a given raw material.
So just to pause here to understand how valuable this is, right? So imagine if you have a SQL team and each one is writing SQL queries, and then instead of you going and rewriting similar queries that someone else has written before, you just put them into a tool that everyone can reuse. So you don't have to write and rewrite same stuff. So it's like a common definition of queries across the business, really. And
Exactly.
then, as an extra step, it can be leveraged by agents and agents.
That's a really good point, actually. Also, the reusability, the discoverability, because it's in Unity Catalog. At the same time, it's still safe because you can govern this function in Unity Catalog. If this is a function that can query, people's salaries in a company, surely you don't want anyone else but the finance team to have access to it, for example. And so that's what I love. You can make it accessible to as many people as possible, but at the same time, you can restrict access, and it's all governed within Unity Catalog. So yeah, that's a really good point. So we have those functions, but we don't stop here. We're going to create more functions. So we're going to create one that can query our Genie space, as if it's an API, so our structured data. And then obviously you don't need to query a Genie space. You could also just create a function that queries tables directly. So I just put an example doing this. And then we're going to create another function that can query the vector index with all of our emails so that I can get information from those emails. And so it's very much the same here. So an agent that you can converse with to get answers to questions, etc. So here it's a function that queries the Genie space. But also, if you want, you can just register a table query tool to query a particular table.
So then the difference between hitting the Genie API versus using a SQL tool, in my mind, is that in the Genie, when you hit the Genie API, you actually pass any query you have in mind in natural language processing. Whereas when you are hitting the tool, the query is predefined, is the query that the tool executes. So it's much more restrictive and specific, so it cannot go crazy. Where in Genie, you can ask it any question, really.
Exactly. Yeah, Genie is just a text-to-SQL agent where you ask questions in natural language and it returns the information by doing text-to-SQL, which is very powerful. So here I was just testing that my vector index was working, which it did. And so based on this, then I also created a function that queries I called it unstructured emails, a bit redundant, but yeah, queries the vector index. And I put again a comment saying those are emails sent by distribution centers or sellers explaining the delay so that the LLM knows what we're talking about. You can also create functions that can execute code because sometimes LLMs are not the best at executing codes or at doing math, for example. So that's also something, an example that I put here that you can add to your agent, etc. And now we have our functions. And actually, just before we start, we can go into the Genie space to just show very quickly what a Genie space does, right? So here, I registered some tables, right? So the tables that we defined. And here you can see the power of Genie, where I'm just going to start so that it stops showing. But you can ask questions such as, what are our top 3 forecasted raw material shortages? And here it gives you this. How much revenue is at risk if we can't produce the forecasted amounts? Here it says, what you gave me does not include information on this, so I cannot calculate it. I love that here doesn't hallucinate and give me just a fake answer. And it
Very
says, hey,
important.
give me relevant data. What I did do was like to go and all those functions we just defined, I just added them here. All right, so like you have this revenue risk function product from raw. So I added that and now it can leverage it. So as soon as I did that, then it said, hey, I found a function that might match your question. And it did that. And based on that, it could calculate the revenue risk for this material that was identified as one of the top 3 forecasted raw material shortages. So I just really love it that you can add all the
Beautiful.
functions and then you can just leverage it. Then I can
Beautiful.
deep dive further. What products are dependent on this material? And then it is going to return products. So for example, here, autoclave or whatever. Which plant to distribution center route is running the most products? So here you get your answer as well. Which distribution center has the highest chance of being a bottleneck? This query identifies the distribution centers with the highest forecasted demand, which indicates a potential bottleneck in the supply chain, etc. Love it. The reason we're building an agent, because people can ask, why do you need an agent? I have this, I have everything I need. Key thing to remember, it's only structured data. Here I cannot add my emails, I cannot add my scanned invoices. It's only able to leverage structured data. You can add instructions, you can add functions. It's very powerful, the Genie space, because you can give general instructions and say, hey, in my company, we call this with this acronym, etc. I just really love it. You can add example queries to force it to execute certain type of SQL, to answer particular questions so that you get some really trusted quality answers.
Interesting. So if you find it hallucinating in something, you can go help it with what kind of SQL you would expect it
Exactly.
to have
And
written. Okay.
your data consumers are people who do not know SQL, who are not technical, and keep asking questions around structured data. And if you find yourself always building dashboards and having to always build more and more and more dashboard, maybe you need a Genie space so that people can ask lots of nuanced questions around your structured data. So yeah, customers love the Genie space. We see a lot of interest from it. But we don't stop here, because here we defined a function, that is going to leverage it. But now we're going to build an agent. And the easiest way to start with this, you can go into our playground. You can use any model. You can add all those functions as tools. And then you can ask questions in the playground, and it's going to leverage those functions. So let's go into the playground, and that's going to be a live demo. So I can choose, for example, an external model. Let's go for GPT-4o. And let's ask a question like, what are our top 3 forecasted raw materials? Okay. And here we haven't put any tool yet. So, I mean, it's nice. Thank you for the answer, but it's actually not very relevant at all for my supply chain, for my company. And this is why you want to add those functions. So here I put them as notes here.
So interesting. Now it's just answered based on ChatGPT for all knowledge.
Exactly.
Right? There is nothing relevant to our business.
Exactly. It's based on what GPT-4 was trained on, which is, data on the internet, Wikipedia, whatever it can find and make sense, I guess. So let's add some tools. So I'm going to add all those functions we just defined. So let's do it here. So you can recognize everything that we defined before. So here we get the row from products, and then the product from raw. We have the revenue risk. We have the one that allows us to query our Genie space. And then finally, the one that allows us to query our vector index. All right, so now let's ask those questions again. And so, for example, here, what are our top 3 forecasted raw material shortages? I'm going to copy this already now while it's thinking. So now, GPT is now thinking. It's still thinking. And so here, it said it's thinking again. Like it's saying, in order to do this task, I'm going to query the pharma supply chain dataset using the Genie Space API. This will provide the most relevant and up-to-date information. It gives the output, and then it wraps it up in a nicely formatted answer, which you don't have in the Genie space. You know, it's just a text to SQL. I love that here it then wraps it up in a really nice answer. So now let's ask how much revenue is at risk. If we can produce, the revenue at risk is approximately 53,000. All right. And then what products are dependent on this? We can also, and it also suggests some questions that you can ask it.
Oh, nice.
And you can see we see the same answers that we saw, you know, in the Genie space. Now, what are the delays to wholesaler? Number 9, and that is the question we could not ask in the Genie space, right? I need to query the email sent by distribution centers to wholesalers. It typically contains detailed explanations of any delays. I mean, I love it. It also explains how it thinks. So you can, if you're not happy with the answer, you can, you know, troubleshoot this. And so here it retrieved all the emails, and then it gives you a nice little answer. And of course, every time you can see with tracing, so here view trace, you can, you know, deep dive into it. I think we discussed traces in another video, but it basically allows you to examine each step of, you know, the pipeline and examine whether there's a bottleneck, where did it go wrong, is it when it retrieved the emails, or is it, you know, when it wrapped the answer, etc., etc. And now, what raw materials are required for syringe number 1? And so here again, I'm going to use this function that you gave me, and it gives you the answer. Are there any delays with this? Which again, this time is going to query the vector index with all the emails, etc. And then you can ask a follow-up question because it's multi-turn. And yeah, that's basically it.
Very nice.
What I love is that now they give you also the ability to just export that into a notebook, which allows you to log the agent as an MLflow model and evaluate it, and so basically productionize it. And so I think I had logged it previously here, example agent.
So this is all the code you need to re-implement the agent yourself with these tools as a tool set.
Exactly. The playground is good to, you know, get a feel for all the different models, start building an agent and see what the agent would look like. I love that you can get a feel for the answers, etc., before you log a model, like you log the agent. But once it's done, you know, here you have, for example, I replaced it with the question. And so, yeah, it gives you all the starter code that you need, and also some advice. So again, on this, so You can productionize the agent based on this playground which you export. So generating the code to log this agent to ML flow, register the model in Unity catalog, do agent evaluation, and then deploy. So that's what it does, is creating a serving endpoint so that you can serve this agent as an API. You will get all the inference tables with the payload logging so that you can monitor the agent. We already talked about the traces so that you can examine each step. And I love that now we did a dedicated demo on this. So this is going to look familiar for whoever saw that previously. But now we have also like this notebook that's given in the documentation on how to monitor agents, where you can see the request volume, the latency, feedback. When you apply LLM judges, you can deep dive into this, etc. So you can reuse all this logic that we already discussed in a separate video. And of course, you can provide your own custom evaluation. And again, as part of this, I'm not going to deep dive because now it's already quite a long video, but you can leverage the agent framework to log the agents, and then the AI agent evaluation framework in order to evaluate them and make sure that you get quality outputs. And so basically, end-to-end, the way that we recommend to do things is to build a prototype playground, then prototype. We can test it with stakeholders by having people, stakeholders, SMEs reviewing, the outputs with the review app, and then just iterate to improve the quality, the cost, the latency. And so you have a lot of configurations that can be tuned, and then you can serve your agent and monitor it in production. That's it.
Amazing.